Good morning, everyone. My name is Dr. Adam Klett. I'm the Director of Science at Kaizen Corporation, and I'm here in the Global SMT and Packaging booth at the IPC Apex show in sunny Anaheim, California. Today, I am thrilled to be joined by three subject matter experts from across the industry to talk about a subject that is very close and near and dear to my heart, which is cleaning or under-stencil wipe. The panel that I have today, we have Chris Shea, who is the founder and president of Shea Engineering. We have Debbie Carboni, who is the global product line manager for electronics products at Kaizen Corporation. And we have Anna Lifton, who is the research and development director at McDermott Alpha. Well, first of all, thank you, ladies, for joining me. I'm thrilled to start this conversation with you. Now, I'm gonna tee up the first question, and whoever wants to take it can take a swing at it. But can we start off by talking about what is the stencil printing process, and what do we mean by under-stencil wipe?
Okay. The stencil printing process is how we put solder paste onto the board before we place our components on it. We stencil it down with a squeegee in a process that was evolved from t-shirt making back in the 1980s. When we do that and we separate the stencil from the board, a lot of times the paste strings, and those strings snap back and end up on the bottom of the stencil. If we don't wipe that, we redeposit that on the next board, which can be a problem, or we don't get good gasketing and we get bad printing, which is why when we see too many bridges, we cue a wipe. Does that make sense?
Yeah.
Okay.
So when you think about the different IPC classes and all the different manufacturers that build electronics assemblies, a lot of people don't clean their boards. Are there cases where people can get away with not wiping their stencils, or does everyone pretty much need to wipe their stencils?
Absolutely no, that would be very bad.
Well,
all kinds.
Can you expound on that?
You want more detail? No, you can actually run into all kinds of defects. That wiping process will keep, if you do it right, will keep your stencil on your printer a little bit longer. If you do it right, you're going to reduce the amount of defects that you have. You will also improve your yields and throughput ultimately.
Okay.
Also, while we developing solder paste, we usually run print DOE. We look at the print capability of the specific paste. And one of the tests which we always do, we do the wipe frequency. So we for each paste, we might recommend specific wipe frequency depending on the formulation.
So when can you define wipe frequency for us?
So we will print a couple of boards, we use SPI to measure the volumes, and then we will print extra boards, and then you will measure again and look at the quality of the deposit. So, and I could tell you that this particular paste needs to be wiped every 3 prints, needs to be wiped every 25 prints, but it must be wiped.
So it's automatically assumed that no matter what you're building, you're going to be wiping your stencils.
Absolutely.
Oh, yes.
Okay. All right. So, Debbie, maybe you can answer this question for us. Do we need a solvent when we're wiping? Because a lot of times there are different types of wipes. We saw in your presentation yesterday how you can have dry wipes and wet wipes and vacuum wipes, and a lot of people have their own secret sauce recipes of how they do that order, and do I need a solvent when I'm doing that wipe?
Once you get into certain aperture sizes, you absolutely are going to need an under-stencil solvent. Chris and I have actually worked on some papers through the years, and the data is absolutely outstanding, showing that you are going to stay well within your process if you dial in that wet process. You also have to worry about what type of chemistry you're using. And I think it's really important to understand that the chemistries that were developed, 15, 20 years ago, they weren't necessarily developed for the under-stencil cleaning process. They were afterthoughts and repurposed. Now today, there's a lot of focus and a lot of R&D put into developing the right type of solvents that are going to give you the effects. One of the papers that Chris and I worked on, I think that was last year, we actually learned a lot about how it behaves and how one solvent can give you a quicker dry that works better when you're wiping more frequent, whereas some of your other solvents that are running, a little bit slower of a dry speed, they might be more effective at removing the flux residue underneath that stencil, but they need a little bit more time, so they're better suited for wiping at 10 plus prints.
Just to build on what Debbie's saying, wet wipe always works better than dry. When you have a dry wipe, you do pick up the errant solder particles on the bottom of the stencil, but you basically just smear the flux all across the bottom, which makes that stencil surface stickier, and it's harder to separate from the board, which then, of course, brings in more defects. So just imagine trying to clean your greasy kitchen counter with a dry paper towel versus with a squirt of some kind of solvent. That's the night and day difference you see with wet and dry wipe.
And as a paste manufacturer, we would send samples of the paste to cleaning companies to specifically select solvents suitable for that paste.
That's excellent. Now, you mentioned the different types of wipes, dry, vacuum, and wet. Can you kind of tell us the purpose of the dry and the vacuum wipes?
I'm going to let Chris answer the dry.
I don't do dry wipe alone.
Well, there you go.
A vacuum wipe is automatically a dry wipe. Back in the olden days, when we had really rough stencil apertures and really rosny, sticky pastes, we were afraid to do a vacuum wipe because we thought we would dry out the aperture and the first print would look bad, which was often the case. But that's tribal knowledge from 30 years ago. We now have smooth stencil walls, we have nano-coated apertures, and it makes a world of difference. And we have solvents designed specifically for solder paste.
Yes.
We're not taking a general solvent and throw it in the printer. We're doing things that have been worked through R&D to work on paste specifically. So that's a big difference.
That's great, because I've seen some videos that Debbie presented showing how different fluxes are not soluble in certain solvents. For example, like IPA versus an engineered solvent that's specifically designed for a paste. And there's some pretty cool video.
Yes.
Yeah.
Actually, there was a fascinating discussion I had with one of the solder paste companies, and they said that when they put the sorry, Anna, it wasn't you. But when they put their solder paste in with IPA, it turned it into goo. They had a more descriptive term for it. Yes, I wasn't going to say that, but yes. But yes, and it really makes a big mess on the bottom of the stencil. That can transfer onto your boards. That can cause not only defects but product reliability issues.
Yeah, when we did the UV tracer testing with Mike Bix, and we used IPA, we could see the paste seizing up in the smaller apertures. It was not coming out at all. It was worse than a dry wipe alone.
So it's very important to make sure that you're using a solvent that is designed for the process.
For specific solder paste.
Mm-hmm.
And actually, in the paper that we did just yesterday, one of the things that we did was introduced a dry wipe at every fifth print. And what we actually saw with the UV tracer was that flux building up on the bottom. So at the 5 prints, you saw that flux being smeared on the bottom of that stencil. You go to 10 prints, and it's smeared even more, and it was thicker. So now you're expecting, and oh, by the way, that printer sees a solvent for all of about a second on your standard default settings for most printers. Right. You're expecting that solvent to remove built-up goo, schmutz, that has a second to do it, dissolve it, and remove it.
So that's a great point. Can you talk about the other parameters that I can change on my stencil printer? For example, like you mentioned speed, right? Can I change anything to increase that, or change what other things can I change to help improve what you just talked about?
So I just learned a lot about the parameters that can be changed. Actually, I've learned a lot from Chris on fine-tuning those. But one of the things you can do is change the volume of solvent that goes onto your boards or onto your paper. That is really dependent upon the match between the solvent and the paper itself. A lot of work has not been done in that area to really fine-tune it. Some people don't even change those default settings. The other is that and what we played was the gantry speed. to see how fast that wiper was going across. And we did see some improvements. I think Chris actually has some other areas that are equally as important, not just on the wiper, but in general.
Paper makes a big difference. Back, again, in the olden days, we used this coarse weave polymer paper and hoped that the coarse weave would capture those solder particles. Then particles got smaller. Now we have pocketed paper that helps actually grab those, so that makes a big difference as well.
We actually had an intern during the summer doing evaluation of various paper and counting the defect depending on a paper on the printer.
Have you included the solvent with those papers?
No.
I think that would be fascinating.
But we just looked at different papers, and now we selected one which does not produce as much defects, but we do use solvents as recommended.
So when I'm designing my process, do I need to make sure that I choose a solder paste that is printable and cleanable? Let me back up. Which one should I choose first? Should I choose my solder paste first and then design my cleaning process, or should I do that first and then go and say, okay, this solder paste is compatible with my wiping process?
When we're designing the solder paste, we're running through the printing process. We look at the print speed, print pressure, separation speed, all those parameters, and we select optimal parameters for that paste, and we will recommend. But at the same time, I'm sending the sample to my cleaning companies, and they will, so sending sample of the solder paste to the customer with the specific print parameters plus recommendation for the cleaning, it's a part of the package.
When an assembler is selecting a solder paste, they need to select it for their process. And one aspect of their process is compatibility with current underwipe chemistry and current cleaning chemistry. Not to burst any bubbles, but that would not be the number one criteria for solder paste selection. It would be printability, because that's the first thing people look at. Then it would be reliability and cleanability as things go along. So you match the solvent to the paste, not the paste to the solvent.
Sorry, Debbie.
I know. I used to think it was my world.
So is there a printing parameter that you would say is significantly more important than any of the other printing parameters, like speed or how much solvent gets onto the paper or the selection of the paper, or would you say that they're all equally important? If I can
make any paste bleed by changing the angle. So that
a good process engineer can make lousy paste print well.
Yeah.
Because they've got so many tricks up their sleeves. In general, we want a paste that anybody can make print well.
So you mentioned that a good process engineer can make even a poor paste print well. What factors play into it? What kind of tricks are you talking about? What are, or maybe to ask it a different way, what are some of the best practices when stencil printing and considering the under-stencil wipe?
Ooh, that's a good question. I've found with a lot of the modern pastes right now, they've got big wide open windows for speed and pressure, and that's a good thing, and I would agree. Also, they're more sensitive to separation speed than they were in the past. And typically, a fast separation speed will give you a nice, clean release. If you take a slow separation speed, you're going to develop those strings that schmutz up the bottom of the stencil. So, yeah, it's speed and pressure are pretty easy. Separation speed is a key, and wipe frequency, which often depends on the smallest apertures or finest pitch you've got on the board.
Okay, because I would guess that we would want a very low wipe frequency. We want to be able to wipe as little as possible. Is that an accurate statement?
Yes, because it takes up cycle time.
Yep.
Exactly. What's a standard? How many wipes, or what cycle time is considered good? If I could say, hey, if I get my process to wipe every 2, 5, 10, 20. What's considered good?
Depends on the tack time of the line. So your placer is the most expensive piece of equipment on the line. That should be your gate. So your stencil printer should not keep your placer from placing. So that all depends on your line. Like If you have 30-second tack times, oh yeah, you got plenty of time to wipe. If you have like 11-second tack times because you're high-volume mobile phones, you don't have as much time to wipe.
It's a very good point. You just want to make sure that you're not the bottleneck in the process.
No. Considering a placer is like 10x the cost of a printer, yeah, you want to utilize that placer as much as you can.
Very good point. So, Anna, maybe you can answer this question. Is there a difference between no-clean pastes and other types of like water-soluble pastes when it comes to the stencil printing process and wiping? Are there any special design considerations, or from the user perspective, or there's no difference?
It's all depends on paste formulation. So the only issue with water-soluble paste is when your humidity and temperature is a little bit off. But when you have a right condition in your printing, water-soluble or no clean paste, there's no difference. It depends on a formulation. Even within the same families, they will behave differently.
So the last kind of topic that I have to talk about here is costs. Wiping costs money. In a couple, there are different costs associated with it. You can think of the time that it takes, right? If every time I wipe, I spend time, which is not great. But then there are also consumable costs. There's the paper, there's the solvent themselves. And I've heard people say, well, I'm either just going to use a dry wipe or I'm not going to wipe at all because it costs money, and I can deal with the defect rates, and I see you all shaking your head. Tell me what's wrong with that train of thought.
What does it cost to rework a single BGA? Over $100. What does solvent and paper cost? Not $100. How many more defects are you going to make by not wiping? How many more hundreds of dollars are you going to lose because you're tripping over pennies?
100%. And to add to that, working on understanding what those costs are. A lot of people say, well, I'm going to have the lowest cost chemistry in there. I'm going to buy the lowest cost paper. What they don't realize is by doing that, they may actually be costing themselves more because they're going to have to wipe more frequent, so that's more paper. They are going to have to use more solvent. That's going to be more cost, and a lot of times those cheaper solvents are, especially IPA, is probably the number one misconception. The amount of volume that it evaporates at is significant. So now you have to put more material on it, and you're going to consume more.
And as a paste supplier, I never even think that people will not wipe. I'm like, you have to.
You're not designing it to be.
No,
it's not
absolutely
like
not.
You design the no clean fluxes so that maybe they don't want to clean,
No.
they don't clean. But there's not even a thought.
I never thought of yes, you will. All I can recommend how often you need to wipe, but not wiping ever.
Yeah. Because I've seen cost models where all of the parameters that you just spoke about, Debbie, things like the amount of paper that you use, the amount of solvent that you use, all of those things, although technically you may spend more money per liter of cleaning solvents, right? You're actually saving money in the end. What's the expression you say? Cost per.
That's a good question. I just drew a blank. Cost per wipe. Cost per print.
Yeah.
Cost per wipe.
Per print, not per liter.
Cost per liter. Mm-hmm. Yes.
Yep. Well, that's fantastic. Do any of you have any comments, anything that you think that our viewers need to hear about when it comes to under-stencil wipe?
I've got 3 famous takeaways.
Let's hear them. Board sport. No.
Exactly.
Yes.
No, and I forget my takeaways. Okay, wet wipe is better than dry. The paper matters. The quality of the paper matters. And always give enough time for drying before moving on to the next step of the process.
Yep.
Well, can you expound on that last statement? It doesn't have to be super brief, but what do you mean by that, and why?
Because you don't want to put a wet stencil back on the board, and you don't want the solder paste that you're printing through that wet stencil to be diluted as it gets on the board. So you want it nice and completely dry, which is why drying time matters.
Yep. Absolutely. And the other thing I would say is nano coating does make a huge difference. And a solvent's not going to replace it, but it is going to, combining a solvent, the right one, with the solder paste that you selected best for your process, along with a nano coating, it gives you so much more process stability.
I think we dubbed that the triple play. Me and
I like
Bix
that.
like
I
years
like
ago.
that, yeah. Well, it sounds like it's unanimous that under-stencil wipe cleaning is extremely important. It's not even considered during the manufacture of the paste itself. You know, it's assumed that it's automatically done, and that there are knobs and that we can tune to make sure that we get the highest yields out of that process, which involve things like, you know, the selection of the chemistry and how much chemistry and the wipe speed that you mentioned and things like that.
Absolutely.
Right.
Yep.
Well, thank you very, very much. I really appreciate your time coming here and to talk to us about under-stencil wipe. I think I learned a lot. I hope our viewers did the same. For those of you online watching, thank you for tuning in. This has been a great live panel discussion here, and we look forward to seeing you in the future. Thank you very much.
Thank you.
Thank you, Adam.
Thank you.
Synchro. Join the revolution. Non-stop selective soldering. Increase UPH. Reduce maintenance. Small footprint. Contact us today for more details.